Good afternoon, good day all. This is Anirban. Today I wanted to show a demo of a chatbot I have built. This is basically connecting the chatbot with the agentic RAG that I had shown in a previous session. And also I've used image extraction, extracting the information from the images within the PDF. So I'd like to show this chatbot how it works by combining elements from various frameworks and extracting the information in a holistic way, right? So my chatbot design is very simple using Streamlit, and my source documents are basically the same PDFs that I had shown on one occasion earlier. These are the PDFs, the educational PDFs written by Dr. Tirthar Pratim Das from ISRO, the Lunar Saga, and the introduction to space exploration, and also the solar system exploration and India's contribution, a beginner's guide. So this time it's truly a multi-document agentic RAG. Last time I showed the agentic RAG in a multi-document way, but I used one PDF. This time it is truly a multi-document agentic RAG. It will pick up the correct document on the fly and generate the answer. So without much ado, I'd like to show a demo of the chatbot. To run the chatbot, simply Streamlit run chatbot.py. I'll share the code at the end of the session. So for example, if I ask, what is India's latest moon mission? India's latest moon mission is Chandrayaan 3. It answers very cryptically. We can even ask what are the objectives of this mission. So when I say this mission, it should be able to infer from the context that I'm talking of Chandrayaan 3. So it says the objectives of Chandrayaan 3 mission are multifaceted, and it gives soft landing on the moon, rover deployment, scientific experiments, etc. We can even ask what are the scientific experiments on board this. So the chatbot, basically the way it works is it keeps the previous conversation in the context. That is basically the essence of a chatbot, and this Streamlit chatbot is no different. So when I ask, it says that the scientific experiments on board this, it understands that I am referring to the previous context, which is Chandrayaan 3, and it says that Chandrayaan 3 mission is with this experiments, right? Seismic studies, mineralogical analysis, thermal property analysis, plasma studies, etc. You can even ask, was this successful? So it says very clearly, the mission marked a significant, it achieved a soft landing on August 23rd, it was launched on August 5th. Okay. So I'm continuing the conversation and I'm seeing how far it works. It should be able to answer it based on the context of the previous conversation. That's the basic idea of a chatbot. And if we have to start a new conversation, we basically type exit. It's given here. We can also have a button to start a new conversation. So it says, yeah, the unique achievement of Chandrayaan 3 mission includes a successful soft landing near the lunar south pole, etc. the deployment of the program rover for in situ analysis. Pretty good answer. So this is how this bot works, and on the behind the scenes, it basically invokes the agentic RAG using llamaindex, which in turn uses openAI and MistralAI, right? It creates a summary index and the vector index tools comprised of summary index and vector for each PDF document that we have. We have 3 PDF documents, so there are 6 tools, and using this combination of tools, the agent picks up which is the best option for this answer and goes for that tool and gets the answer. The chat history basically is fed to the chatbot in the context. Now, so there is something about this chatbot which I worked on for some time, and I wanted to show that. So I'll start a new conversation here. Let's say I ask, what is the mass of the moon? This is a pretty specific question, right? It's not about just a generic question, very scientific question. What is the mass of the moon? Now we see that the chatbot fails to answer this. The mass of the moon here in any of the PDFs is not given as part of the text. It is actually given as part of this image. As we can see here, page 15 of this lunar survey image contains details like the mass of the moon, the mean density, and etc. Right? Now, how is it that we can extract this information from the image and answer this question? Right? That is the main task I wanted to achieve. So, what I do now, I have added a feature in this chatbot to search the image. So, when I don't get a satisfactory answer from the text, I can click the search image button. So now I click the search image button because the answer was moon is about 80 times lighter than the earth, which doesn't answer my question, what is the mass of the image. Click the search image button, and as we can see, we should see it should be the mass of the moon is 7.347 into 10 to the power 22. We can also ask, what is the mean radius? We can exit this, start a new conversation. What is the mean radius of the moon? It gives, probably this is given in the text somewhere. So all these things, it will give with a combination of these things. What is the day side temperature of the moon? Let's see. So it gives this answer, pretty good. And even search the image and see what answer we get from the image. We go back to the previous question. So we can find some information from the images which is only there in the images, I thought this is one such example where the mass is not there in the document or the mean radius, and as we can see, it is now getting this information from the images by searching the images, right? Let's come back with the answer by searching the images. And so it gives me the instruments on Chandrayaan 1, and we can check it from the document. So sometimes we can compare the results based on the answer from the text and based on the answer from the images. So we can see that the answer from the images in this case was a better answer, right? It gives list of the instruments from the Chandrayaan 1, right? It was orbiter, did not involve a landing on the moon, right? The mission helped confirm the presence of water, achieved more than 3,000 orbits around the moon. Pretty good answer. We can search the images for the same mission and see what comes out, and we can make a choice which is giving me a better answer. And this is one way I thought of. Uh, there is other ways also that we can extract all the information from all the images and put it in a vector database and search at once. But I thought that's not a very good way. We need to index the images and get the information from the images as well, right? So with that, I'll go into the design of the chatbot. While this answer is retrieved from the images, the image retrieval is a little slow because it's comparing the answers from the 3 different PDFs from all the in the PDFs and getting the best answer. OpenAI. So we can see the answers getting printed here. So my chatbot design is very simple. It basically uses the concept of storing the chat history in the session. So we can see the answer from the images. Pretty much the same. So in this case, pretty much the same answer we are getting when we are querying the text from the PDF as well as the image from the PDF. In some cases, the answer could be different. Like when we asked for the mass of the moon, we didn't get a specific answer from the text, but we got a very specific answer from the images, right? So that is also there. So with that, I'd like to go into the discussion of how I build the chatbot. So basically, while building the chatbot, I use this reference from Streamlit, where they have given how to develop the chatbot. I can add it as a reference, in fact, in the code. at the top. That will help. So basically here somebody may say, why not use a langchain concept of chatbot and conversational memory, conversational summary buffer memory. Now what we have seen from our experience is using a chatbot, using a framework like Streamlit, which has a native Python support and runs on the server side, right, has its own advantage. The reason being, for some customers we have seen, they don't expose the LLM directly to the developers. They have a wrapper around the LLM, and all they expose is an API which is coming from their environment, and this API internally calls the LLM, be it openAI, be it Gemini, or whatever it is. So in such scenarios, when APIs, the endpoint API is all we have got, a Streamlit chatbot makes a lot of sense, right? So the basic concept of chatbot is very simple. For those of us who are coming from the Java background, or even those UI developers who are doing today, we all know that when we develop a web app, there is something called a session scope and a request scope. A session scope is something which here in the session as long as the user is interacting and the session is not invalidated due to whatever reason. So basically what this chatbot does is very simple. It keeps the chat history. So we see that the chat history is initialized blank and it is there in the session. If not in st.session state, we maintain this variable st.session state chat history equal to blank. We also maintain few other variables in the session, things like the conversation counter. So when I'm using follow-up conversation, how many conversation I have had from the beginning, right? I can start a new conversation or I can follow up on the same conversation. That's my conversation counter, right? So and I'm also keeping the query the user is asking in the session. This purpose is different. This purpose is all different because I'm having a search image button over there. So when I go to the search image button, it's a different request. So unless the query session, I cannot access that query variable. So that's the reason. But basically, if we see when we press the exit, when we say exit, we are starting a new conversation, a new chat. So basically all these variables are refreshed and the conversation counter is set to 0. If not, that means I'm asking a question, be it a follow-up question or a normal question, a starting question, the conversation counter is incremented by 1. And what we see here is every time the conversation every time the chat history session variable gets appended, prompt and the response pair. That's the main concept of the chatbot. The prompt response pair is appended to the chatbot. So if the conversation counter is 1, basically it's a beginning, right? I give the context as a input and right, and current conversation, though the chat history is blank, and the query asked by the person. So the query is the input is the query, chat history is the chat history, the context is the context. So what is the context here? The context is coming from the invoke agent query with the agent. So what is the invoke agent doing? So basically it's querying the agent. Where is this agent initialized? It is initialized at the top using a cached resource. So I say multi-document agent is equal to multi-document agent, and I provide path where my PDF files are there. So this agent loads up with the contents of this PDF files at the beginning, right? So that is one part, and the other parts of this chatbot are if the conversation counter is greater than 1, that means it's a follow-up question, right? So I definitely have to give the chat history from the session, because that is where my context which I had given previously and the question the user asked previously, the response from the AI is stored, right? I am appending that. So in the prompt template, I now provide the chat history and the input. I don't provide the context from the search because my search is done already. I have the information, and now I'm providing the chat history. The chat history includes the context, right? So when I say the prompt, this prompt for the first question already had the context inside it, right? So I only provide the chat history and the query. And I say response equal to llm.predict. So here I'm using the LLM, I'm not using the Agentic RAG anymore. The Agentic RAG is used for the first basic query to get the whole information from the summary index and the vector index from the appropriate document, right? And now for the follow-up question, I am using the LLM.predict. Where is this LLM defined? It is defined at the top, saying LLM equal to chat OpenAI, model is GPT-4 Turbo. Now I can use MistralAI also over here. If I use MistralAI, I have to use LLM.complete, only syntax change, but I have done that also pretty good. The OpenAI results are better, it looks to me, but I leave it to the user to comment on that. So that is a basic thing. And another thing can happen when I'm doing follow-up queries. What we have seen typically, it might give an exception. The exception handling is important. The exception might come most often because of the token length limit getting exceeded. If that happens, what we are saying is the chat history is equal to get summarized context from the chat history. So we pass it to a summarization method. All it does is it basically creates a prompt saying please summarize the current conversation within so many tokens, and we say use the LLM to get the summarized content. So get summarized content, right? And we use the same loop to predict the answer with the summarized content. And finally we write these things in the console. So here there could be other variations to write the entire chat history in the console. Here I am writing the most recent query and the response in the console, as you could see, right? Now here is the environment I did. I saw that for some options, as I was showing, the answer is not coming from the document. So for example, if I ask what is the mass of the moon, so it is not coming, right? So the moon is about 80 times lighter than Earth. So when I search the image, I find that that answer is much more accurate because it is then coming from. So it's now here there is another thing happening, as can be seen, that it is responding with mass of the moon is this, which is coming from this particular document, page 15, as I showed, right? Reading this image and getting the answer. So how that is done? There I am calling the image extractor dot get response. What is this image extractor? It basically uses chat Google generative AI with a Gemini 1.5 flash. So in this, what I'm doing is I'm passing all the images extracted from a certain document, right, from this file path. And basically, as we can see, we are looping through the directory for file in os.lister. I'm getting the images and putting it in an array, right? And once I get this array of images, I'm constructing a JSON object which has all these images in the query, not just one image, right? So image data is nothing but os.path.join base star file get image data. Get image data in turn actually is what it's doing. It's encoding the image, 64 encoding the image with a decode of UTF-8 characters and all that. So this is important. If you take off any of this, the Google generative AI doesn't work, right? So 1.5 flash has this unique ability, and we are using the langchain provided by chat Google generative AI. So it's a combination of langchain and llamaindex over here. The chatbot. So that's one advantage of using a chatbot using Streamlit as well. We can use a combination of works to achieve our goal. So we are not restricted to any one framework. Here I am using llamaindex for the Agentic RAG, and langchain chat Google generative AI for extracting information from the images. So these images are being passed in a loop, and I'm then getting the answer, model.invoke. That's it, right? So this is the syntax by Google, but all I'm doing is I'm programmatically constructing this JSON with multiple images, right? So the actual code given by the Google is very simple, and we can see it. So I'll show that. Probably this one. Yeah. So this is the syntax given by langchain or Google, that put your image and get the answer. So So here also I am using multiple such these things to extract the multiple such images to extract the right. So coming back to where I was, so image extractor. So yeah, so multiple such things. Now there is another twist to it. Now since I have multiple documents, I could have put the images from all the documents into one folder and put it to Google, get the answer. But here I am facing a problem of exceeding the context length, right? The maximum token exception. So what I'm doing is I'm getting the answers from each of the PDFs, right? And if any better suggestions, I can look into that, how to index the images and hit the correct image at the first go. I couldn't find any way of doing that quickly, apart from extracting the information from the image and storing it as a vector index of the text. That's a different thing. But using the images directly, so I am not sure. So what I'm doing is I'm having three responses from the three sets of images from the three PDFs, and then I'm passing it through LLM, which is in this case is OpenAI, to get the best answer. So here, as we saw, we got, when I asked what is the mass of the moon, one document has it, so it gave the mass of the moon is this. The other two documents doesn't have the answer. So when I sent all these three answers to the LLM, the get best answer, what it does is, you are a helpful assistant, do not use external information, select the best answer based on the query and the three responses provided. So the three responses coming from Google Gemini Flash, I pass it to LLM and I get the best answer. So in this case, the best answer was the response 1. So I printed the response, it says response 1, and here we can see if the response is response 1, then I know yes, the first response from the image extractor was the best answer, and that is what I pass as a output to the chatbot. So here is one more thing I did. This is due to the limitations of the Google Gemini, which definitely will face, because I could have 10 PDFs also. So here is where we need some kind of optimization. But just wanted to say that. So the image extractor is written in a object-oriented way with a class, and to test that, I have given this test function also, where we just instantiate this image extractor and get the response by passing the output folder and a question. And this is exactly what is being replicated within the chatbot. So this is just a driver program to test the class whether it's working or not. In the same way, I have the RAG agent, the multi-doc agent, which is using llamaindex. It is creating the store index and the summary index, and basically it is for all the files in that path, it is going to do that. But here I am persisting this index, that I don't keep on loading it every time, right? So that's why I have named the indexes, and based on the index names, I am checking the index is available, then I will not load it from the beginning. So if the chroma.collection count equal to 0, then only I will do the chroma vector and all that, splitting the documents and storing it as an index and all that, loading it as a vector index by chunking the documents using sentence splitter. But if it's not that, it means my chroma database is already there, persisted. In this case, my persistence is a simple folder path on that. But if I get that, then I'm not going to do this stuff. I'm going to avoid all this stuff and just load the nodes from the vector index. So that is working. There is some lacuna in that. What I found, node count while persisting from the scratch is a little different from the node count when I'm getting what I'm getting when I'm loading from the path in the disk. This is a kind of limitation. I researched a lot. There is no direct of loading the vector index, llamaindex vector index from the nodes. Basically, I need to get the nodes and the vector index from the persisted path. So this is what we have, and that's what I'm using. So I was printing the length of the nodes, and if you see the length of the nodes, after persisting it gets changed a little bit, and I'm not sure what's the reason for that, but still the answers are quite good. There's one other important thing I wanted to point out here, that is llamaindex by default uses OpenAI, right? So what happens if I don't want to use OpenAI, I want to use So continuing from where I left off, so basically what I was saying is OpenAI can be a bit costly. So llamaindex by default uses the model, but here is a quick way to use like MistralAI and the open source Hugging Face model to index the docs. Indexing the documents can be quite intensive. There will be many tokens needed. We are creating a vector index, number index. So all we need to do, I've tested this, we just uncomment this. It then uses the MistralAI uh, as the embedding model, and the MistralAI as the LLM, and the Hugging Face embedding this particular model as the embedding model, while generating those vector indexes and summary indexes. So this is a small is needed in the getDoc tools, what takes care of the whole thing. So this I've already tested. I'm not going into that because I have to recreate the indexes by deleting them, because the vector embedding vector dimensions will be different with this model and with OpenAI embedding model. So it will not work with the same indexes. So I cannot reload them when I'm changing the model. I have to recreate those indexes. It takes about three to 4 minutes. That's one part. That's one thing that's very important, because MistralAI is built. It's not open source, but the costs are much less than OpenAI. That's what I feel. I got the feeling, and somebody can verify that. The other point that I had here is I wanted to show a demo of the multi-document agent using the test agent. So for example, if I ask a question which is specific, which is found in one document, how works by how do we know that the multi-document agent is working? A proof of that quickly. So for example, something that we can from the particular document, and we can know whether it's working. So I'm trying synotic period. Let's see. So I ask this question, and in this output.txt I'm writing the source nodes, the metadata of the nodes, just for a verification. So I'll delete it off, and if I run this, test agent.py. Okay, I misspelled it. Let's see. Oh, it's not going to work, because I went here and uncommented these lines. So it's downloading this embedding models, and now the vector index is not going to match. That's not what my intention. Concept related to the phases of the moon. So if we see in the output.txt, it to concept from the Lunar Saga edition 2, right? And we can ask another question. Let's say to make it simple, just to see that it's working. That's the only thing. So it is using 6 tools, a vector index and a index from the llamaindex for each of these documents. So that's why there are 6 tools. That's what it's saying. It's loading these files. There are 6 tools. Now it's trying to answer, and the agent will find out which is the document to be consulted for this. The answer is pretty good. Chandrayaan series, Mars orbiter mission, and all that. Aditya, it's given all that. So it is being appended actually. So we can see now here it has come. So actually, since I've written the file in append mode, it's showing first the Luna Saga. So we re-ask the question, we can see what are the metadata of the files from where it's getting the answer. So now the output.txt, and we can see the answer has come from Solar System Contribution and India Contribution.pdf. So we can see this is a verification that based on the question, the agent is able to pick the relevant document and give the answer. Pretty good answer, and so that is a verification that a driver program for the agent, which it's the same code that I had earlier, but basically I have made it a bit object oriented so that I can call it from the chatbot. And as I said, I've also made changes to load the index if it's already existing, which is happening in this scenario. As we can see, it's not creating the index, it is loading the index from the stored persisted path. Right? And if I, as I was saying, I can change the model from AI to MistralAI or some other by just by these two lines, the embedding model and the set LLM. I have tested this works very fine, but only in this case the index has to be recreated. I have to read the indexes created in the persisted path over here and recreate this, because the embedding schema will be different, the dimensions will be different. So with that, I'm coming to an end of this session. I'm giving all these things in a GitHub repo, which I'll be adding to the end of this, to the description of this video, YouTube URL. So hope you like it. What I was trying here is how to create a chatbot using Streamlit. What I found is the control is much better in Streamlit. I can do the summarization based on my requirement. I can call the LLMs based on my requirement. I can call multiple LLMs, the Agentic RAG, or maybe an image extractor using Google Gemini 1.5 Flash, get more specific info from the images. All that control is there if I'm using a UI-based chatbot, UI library-based chatbot like Streamlit, and I can also use multiple frameworks like llamaindex, langchain, what I need, right? And I can make it a rich UI as well. It requires some UI skills which I don't have at the moment, so my chatbot is simple, but one can add more stuffs in the UI and Dockerize it and deploy it, right? So with that, thanks whoever is seeing this, and hope it gives some information and some information to people who are working in this area. Thank you.